Welcome again. Let's talk about advanced chemistry, chemistry 2 with Pastor Dan. We've been looking at bonding, we're looking at ionic, and we're looking at covalent. When we talk about covalent, we talked about polar molecules, polarity of polar molecules. Now, what these are covalent molecules with an opposite charge across it. And to cause a truly polar molecule, you need two things. You need hydrogen, which will be the bond, the electron will be at the bond, so there's nothing to cover that. That's all positive. And then we have what are the non-metal attached to it, so they'll have the unbound electron pairs on there, and that will be negative, positive, negative, opposite charges. That gets us polar. Now, we do have something called a dipole moment. All covalent molecules have a slight polar nature to them based on the bond. Okay, the definition of dipole moment is to determine a temporary or slight ionic charge in a covalent molecule. And this has to do with electronegativity. Electronegativity is a measure of the pull of an atom on its electrons. Fluorine is the most strongest pull. 4.0 is a value associated with that. And so that's what we get from there. Now, the equation we use for dipole moment is micro is equal to Q times R, where micro, R is the bond length expressed in angstroms, and an angstrom is 1 times 10 to the negative 10th meters. Q is the dipole moment constant. That constant is 1.60 times 10 to the negative 19th coulombs. And micro is the dipole moment, which is expressed in Ds or dBs, and 1 dB is 3.34 times 10 to the negative 30th coulomb meters. All right, so those are the equations, the units we're going to need to do problems. We're going to do 3 problems, working through each of the different values. So here's the first. And one more thing we need to discuss is the fact of magnitude of charge. If a bond is completely has magnitude of charge, then the value of Q is 1.6. But we can have less on that based on the nature of the bonding. So we need that additional value of E in order to find out how stable that bond is and how strong that charge is. All right, so let's take a problem. The bond length of sulfur oxygen is 3.09 angstroms. Find the dipole moment. So we use our equation, micro is equal to Q times R, where micro is unknown here. Q is 1.60 times 10 to the negative 19th coulombs, and R is 3.09 angstroms. Now, we didn't mention a magnitude of charge, so we assume that it's 1. All right, so that being the case, there is our Q value and our R value. Now, we need to get rid of some of these values. So we said that 1 meter is 1 times 10 to the 10th angstroms. And we said that 1 dB is 3.34 times 10 to the negative coulombs. So when we do that, coulombs cross out, meters cross out, angstroms cross out, left with dBs, multiply through to your calculator, 1.60 times 10 EE negative 19 times 3.09 times, we don't have to buy 1.
So don't do the times there.
Divide by 1 EE10 equal, divide by 3.34, EE negative 30 equal. We do that, we get 3 sig figs and 3.09. The rest of these are constants, so therefore that's our sig figs. 14.8 dBs, that's our answer. All right, let's try another one. This time, calculate the bond length of a bond with a dipole moment of 5.44 dBs and a magnetic charge. So we are going to give you E here of equal to 0.566 E. So use our equation again. Micro is equal to Q times R. Micro, this time we know it is 5.44 dBs. Q is 1.60 times 10 to the 19th coulombs, but R is unknown, and our E value there is 0.566 E's. So let's rearrange the equation and solve for R. R is equal to micro over Q. Plug our values in.
Okay, so if you look over here, I put 5.44 in for my dBs, and I multiply, just so I see that, 5.66 times my Q to get that figured out correctly.
0.566 times Q, because it's not a complete charge, all over, 5.44 dBs over that, And then we're going to take our 3.34 times 10 to the negative third of the cool meters over 1 dB. And I'm making this positive 10 LV. Notice that or not? I think before I said 1 times 10 to the negative 10th meters is 1 angstrom. 1 times 10 to the 10th angstroms is 1 meters. So my units will cross out, my dBs cross out, my coulombs cross out, meters cross out, and I'm left with angstroms. So we take 5.44 times 3.34 EE negative 30 times 1 EE 10 equal, divide by 0.566, equal, divide by 1.60, EE negative 19, equal. When we do that, how many sig figs? We're going to have 3 sig figs. Answer is 2.01 angstroms. All right, that's the answer. All right, so the last one. I want you to pause and try this on your own first. Find the magnitude chart. So we're going to solve for E. So what's the value we haven't solved for? That's what you're going to solve for, and then work your value through. So do your best you can. Remember, any questions, ltswpd@gmail.com. Also remember, like, subscribe, share. If you have any questions, let me know. All right, so here we go. Find the magnitude charge. Those are our values. Rearrange the equation, plug them in, get rid of my dBs into coulomb meters, get rid of my meters into angstroms, get rid of my coulombs into E's, and my angstroms are going to cross out as well. Okay, left with E's. Answer is 0.2403 E. That's it. Hopefully not too bad. Take care. God bless. Bye.